In this video, you'll get a clear breakdown of all 9 hazardous materials classes, what each one means, why it matters, and where the most dangerous mistakes happen. Class 1, Explosives, Dynamite, TNT, Industrial Fireworks, Mining Explosives. Class 1 gets straight to the point. These are materials capable of releasing energy so rapidly that the surrounding air becomes a shockwave before any flame has time to form. And that's where the most common mistake happens. Most people still think of this class as a fire hazard. But fire is secondary. What defines Class 1 is detonation, and that changes the entire response protocol. Distance, isolation, exposure. Approaching the wrong way can be more deadly than the initial event itself. In Class 1, the problem isn't just burning. The problem is all that energy releasing at once. Class 2, gases. LPG, natural gas, ammonia, chlorine, acetylene, carbon dioxide. Class 2 covers gases. And this is exactly where underestimation carries a steep price. Because a gas can be flammable, toxic, asphyxiating, or stored under extreme pressure, and in some cases, all of the above at once. The hazard shifts depending on the type. Flammable gases form invisible, explosive clouds. Toxic gases contaminate with no color, no warning. Cylinders exposed to heat don't just sit there, they become projectiles, or rupture with enough force to completely change a scene. With Class 2, trusting your senses is the first mistake. With gases, the danger tends to arrive before the smell, before the flame, and before the panic. Class 3, flammable liquids. Gasoline, ethanol, kerosene, acetone, paints, industrial solvents. Class 3 shows up in almost every workplace. And maybe that familiarity is exactly why it gets underestimated so often. The critical detail. What catches fire isn't the liquid itself, it's the vapors it releases. A small spill in an enclosed or poorly ventilated space is enough to create an explosive atmosphere. A spark, an engine starting, a piece of heated equipment. The situation changes in seconds. And the ignition point is almost never where the product was spilled. In Class 3, fire often starts exactly where nobody expected it to reach. Class 4, flammable solids, white phosphorus, sodium metal, sulfur, activated charcoal. Solid doesn't mean stable, and Class 4 exists precisely to correct that assumption. This class includes materials that ignite from friction, heat, or simple contact with air. Others undergo spontaneous combustion over time. No external ignition source, no warning, no obvious window for intervention, and some react violently when handled outside of proper conditions. The solid form is misleading because it gives a sense of control that, with these materials, simply doesn't exist. In Class 4, the solid appearance deceives. The danger may be dormant, not absent. Class 5, oxidizers and organic peroxides. Ammonium nitrate, compressed oxygen, concentrated hydrogen peroxide, benzoyl peroxide. Class 5 rarely starts the fire. What it does is worse, it transforms it. Oxidizers intensify combustion and can push a manageable fire into a level of speed and violence, well beyond any initial estimate. Organic peroxides add another layer. They're unstable, sensitive to heat, shock, and contamination. It doesn't take much for them to decompose in a dangerous way. The assumption that, if it's not a fuel, it can't be that serious, is one of the most costly in this field. Class 5 doesn't always start the chaos, but it can feed it until there's no containing it. Class 6, toxic and infectious substances. Organophosphate pesticides, cyanide, methanol, biological samples from medical facilities. No flames, no visible signs. And yet, Class 6 can be one of the most quietly destructive of all. Toxic substances enter through the air, skin, and ingestion, compromising vital functions before the exposure is even noticed. Infectious materials carry biological agents with real transmission potential, capable of causing serious illness in humans and animals. What this class demands isn't just the right gear. It's a technical read of the scene and strict control over who is exposed, for how long, and in what way. In Class 6, the danger doesn't need to explode to be devastating. Class 7, radioactive materials. Enriched uranium, cesium-137, iodine-131, americium used in industrial smoke detectors. No smell, no color, no smoke. Class 7 operates in complete silence, and that's precisely what makes it so serious. Ionizing radiation affects the body progressively, with consequences that depend on the source, the dose, the distance, and available shielding. That's why the response to this class isn't based on instinct or general field experience. It's built on 3 precise variables: time of exposure, distance maintained, and shielding in place. Improvisation here isn't just ineffective, it's dangerous. In Class 7, the invisible is exactly what makes everything more serious. Class 8, corrosives: sulfuric acid, hydrochloric acid, sodium hydroxide, nitric acid, concentrated sodium hypochlorite. Class 8 doesn't need a flame to cause destruction. The mechanism is different, and in many ways, more immediate. Corrosives destroy living tissue on contact, on skin, chemical burns, in the eyes, risk of permanent damage, on metal structures, progressive compromise of structural integrity. And depending on the product, contact with other substances can trigger secondary reactions with their own hazard potential. The absence of visible fire does not mean the absence of an emergency. In Class 8, the threat doesn't burn like ordinary fire. It corrodes, penetrates, and destroys. Class 9, miscellaneous hazardous materials: lithium batteries, electric vehicles, dry ice, magnetized materials, aquatic rescue equipment. Class 9 is where older frameworks meet new problems. It covers materials that pose real risks during transport, but don't fit neatly into the previous classes. And some of the most relevant examples today are tied directly to technology: lithium batteries, along with other products that carry specific thermal, environmental, or operational hazards. This class isn't a footnote. It's a reminder that risk doesn't stand still while the world moves forward. The risk evolves, and the classification has to keep up. In the end, those placards are telling you how an incident might behave before it even fully develops. When you understand these classes, you start to see that hazardous materials aren't just a topic for specialists. They're part of everyday life, and knowing how to identify them stops being a curiosity and becomes survival knowledge. If you don't want to miss the next videos, subscribe to the channel and check out this video right here on Fire Classes. See you next time.